Okay, on today's video, I'm going to go over last class's cool down so that you can see how to work all the problems and hopefully it'll answer any misconceptions or questions that you might have over the product rule and trig functions. So the very first question was, the product rule is, and this is just to make sure you knew the definition of what a product rule is, and basically product kind of gives it away. Product is multiplying. So a product rule is when you use it when you're multiplying two or more functions together. And that is all you have to worry about on what is the product rule. On example number 2, we're asked to find the derivative of this function. So let me write that down. We got f of x. And our first term is going to be x squared minus 4x plus 2. And our second term is 2x cubed minus x squared plus 4. And we're asked to find the derivative of this using our product rule. So our derivative would be, we take our first term. So let me kind of identify these. This will be my first term, so I'll use red to note it. And then this is my second term, and I'll use blue to when I use my second term. So going back to our first term here, so our product rule says you take the first term and you just copy it down just like it is, and you times that by our second term's derivative. So that's going to be 6x squared minus 2x. And then you add the second term just like it is. So that's 2x cubed minus x squared plus 4. And then you multiply that by the derivative of the first term, which is 2x minus 4. So first term times the derivative of second plus the second term times the derivative of the first. And that's the basic setup of any time that you're using the chain rule. And so then I'm going to have we're going to do distributive property here. So I'm going to take this 6x squared and I'm going to distribute to each of the terms in this first trinomial. And so when I do that, I'm going to get 6x to the fourth minus 24x cubed plus 12x squared. And now I'm going to take this negative 2 and I'm going to distribute it to all three terms in that first parentheses. So negative 2 times x squared gives us a negative 2x cubed. And negative 2 times negative 4 gives us a positive 8x squared. And then that gives us a negative 4x. On our other side, I'm going to take this 2x and I'm going to multiply it by every one of the terms in this second. So 2x times a negative x cubed is going to give us a 4x to the fourth. And then minus 2x cubed. And then plus 8x. And now I'm going to take the negative 4 and multiply it by all three of these terms. So negative 4 times this is going to give us a negative 8x cubed plus 4x squared minus 16. And as you can see, I now have all my like terms lined up. And I did it like this, so I can easily add my terms. So I have 10x to the fourth minus 36x cubed plus 24x squared plus 4x minus 16 would be my correct derivative. And that matches up to example A, choice A in this case. Right, and on 3, we're asked to find the derivative of a function. So this is our first time we're dealing with trig function on this quiz. So if y is equal to x squared cosine of 2x, notice that my first term is x squared and my second term is cosine of 2x. So if I'm taking my x squared, so if I'm going to find the derivative of this, I'm going to take my first term, which is x squared, and I'm going to times that by the derivative of my second term. Derivative of cosine is sine with a negative. But notice that this has an inside function inside of that, so we have to apply our chain rule and times this by the derivative of 2x, which is 2. So that's first times the derivative of second, plus, now I'm going to take my second term, just like it is, that's going to be cosine of 2x, and I'm going to times that by my first term's derivative. So x squared's derivative is 2x. Do not combine these together. This cosine of 2x is inside the trig function. That's the reason I like to put the parentheses around it, but it's not required. You have to know that that's inside, so I cannot make that 4x squared, so do not multiply those together. So I'm just going to do some simplifying here. We got a negative times 2, so it's a negative 2x squared sine of 2x plus a 2x cosine of 2x. Now this would be a legit answer, but I notice it doesn't match up with any of my choices. But I know it's close to these last 3, so I'm going to take out a 2x and see what that leaves me with. So a minus 2x gives me a negative x sine of 2x plus cosine of 2x. And therefore my correct answer is this next to last one. Okay, question 4 asked us to find f of x is equal to sine cosine of 2x, find the derivative at pi over 4. So let's start by finding the derivative of this function. So given that f of x is equal to sine of the cosine of 2x, notice that we have the chain rule going on. We have an inside function, which is cosine of 2x. We got sine of some inside function. So that means when I take the derivative of this, I'm going to have to use the chain rule. So derivative of sine is cosine. So it's going to be cosine of whatever my inside is, times by my derivative of the inside. Well, the derivative of this cosine of 2x is negative sine of 2x, but I'm not finished yet because this also has an inside function. So I need to multiply by the inside function. So the derivative of the inside function, derivative of 2x is 2. Simplifying this down, that gives us negative 2x cosine of the cosine of 2x times by the sine of 2x. Now we just didn't want the derivative of that. We wanted to evaluate it at pi over 4. So that gives us negative 2. Oh, there's no x there. That gives us negative 2 cosine of the cosine. Well, 2 times pi over 4 is pi over 2. And then the sine, again, 2 times pi over 4 is pi over 2. Now, this asks, usually unless it specifies, it wants the exact value, so your calculator is not going to help you all that much every time on these special trig functions. IB expects you to have memorized all these special trig functions, so I'm going to talk about that a little bit here before I go up and finish this problem. Now I'm noticing I'm looking at the sine. I have a sine and the cosine. So there's two ways to memorize some of these special angles. And it's either graphically or with a table of values for the first quadrant. I'm going to do this one graphically, and I'll do the next problem with the table so you can see the two methods. So you need to know what sine, cosine, tangent, cosecant, secant, and cotangent's graph looks like. But if you can just memorize the first three, sine, cosine, and tangent's parent graph, you will be able to do so much really fast on the IB exam. So here is a quick sketch of the sine function. I know the range of sine functions from -1 to 1, and I'm just going to do one period of it. So that's going to be pi over 2, pi, 3 pi over 2, and 2 pi. It takes a full circle to get one period of that graph, of the sine graph. And I know that the sine of, and I know the pattern for sine, it starts at 0, 0. You go up to 1, back to 0, down to -1, and back to 0. And that is the wave pattern that you get for the sine. So you just need to memorize that. And then for this problem, I needed to figure out the sine at pi over 2. So at pi over 2, my sine value is 1. So I can replace this pi over 2 sine with 1. And then you also need to know your cosine graph. It also goes from pi over 2, pi, 3 pi over 2, and 2 pi. It has a range from -1 to 1. But the difference with this is now that your cosine graph, so this is cosine of x, starts at 1. It has the point 0, 1 on it. And then it goes down to 0, then -1, up to 0, and then up to 1. It looks like this type of curve wave pattern going on. So if I want to find the cosine at pi over 2, the cosine of pi over 2 is obviously a y of 0. So this is going to now plug in as -2 cosine, and I can replace sine of pi over 2 with 0. But now I need to figure out the cosine of 0. Well, the cosine of 0 is 1. So I can now simplify this down to -2 times 1. And then 1 times 1 is 1. So my final answer is -2, which you can see is the last choice. Okay, question number 5 asks you to find the equation of the normal. So here's the key. We're asking for the normal line. And you had to recall that the normal line is the line parallel to the tangent line. So I'm going to start by finding my tangent line. Well, my slope of my tangent line. So if y is equal to the tangent of x, the derivative of y is equal to the secant squared of x. And if I wanted to evaluate this at the point pi over 6, that's going to be, well, I need to recall a few more trig information. So we need to recall that secant is equal to 1 over cosine of x. I know that cosecant is equal to 1 over sine of x, and cotangent is equal to 1 over tangent of x. Also recall that tangent of x is equal to sine divided by cosine. So these are all going to be important information that you need to know. It's understood, it's assumed knowledge on the IB exam. So here we're looking at secant as 1 over cosine of x. So that means up here my derivative, I can rewrite this as 1 divided by the cosine of pi over 6 squared. Now, if you remember from our last problem, on our graph here of cosine, we don't have pi over 6. It's somewhere in here, but I don't know the exact value of where it is in there. So the graph is not going to help me as much on this problem. So this is where I'd used my other method of figuring this out. And this is the table method of your special angles. Now this works for the first quadrant angles, and then you can use your reference angles for the rest of them. So this, I want to look and find my got a little big there. Okay, so this is, we're going to look at this and we're going to figure out our sine, cosine, and tangent. Now you want to, if you're going to use the table method, it has to be written in that order for this pattern to work. So I always remember sine divided by cosine equals tangent. So this right here is helping me set up, know which term goes where. Sine goes on top. And then our special angles are 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, if we have it in degree measure, 0 radians is 0 degrees, pi over 6 is 30 degrees, pi over 4 is 45 degrees, pi over 3 is 60 degrees, and pi over 2 is 90 degrees. So these are our angles that we're looking at. The pattern is as follows. Let's see, what color did I use for sine? Blue. So I'll keep it in blue. The pattern is as follows. If you can remember this, you can always remember these special angles really quickly. It is, here's how you figure it out. You go 0, 1, 2, 3, 4. Take the square root and divide by 2. And then we're going to simplify this down. So if I take the square root of 2 and divide by 2, well, that's going to be 0 divided by 2, which is just 0. And then square root of 1 divided by 2, well, the square root of 1 is 1, so that's just going to be 1 divided by 2. Square root of 2 over 2 does not simplify down. Let me just write it a little bit neater. And so that's going to be the square root of 2 over 2. And then square root of 3 over 2 does not simplify down either. So that is square root of 3 over 2. But on the other hand here, the square root of 4 divided by 2 is 2 over 2, which simplifies down to 1. Now, that's the sine. So remember, we start at 0, 1, 2, 3, 4. Take the square root and divide by 2. Cosine is just the opposite order. So we're going to start with 4, 3, 2, 1, and 0. Take the square root and divide by 2. Take the square root and divide by 2. Okay, square root of 4 divided by 2 is 2 over 2, which we've already figured out is 1. That does not simplify, does not simplify. Square root of 1 is 1, so that just becomes 1/2. And the square root of 0 is 0. 0 divided by 2 is simply 0. Now to find tangent, I'm going to use this rule. Sine divided by cosine. So I take 0 divided by 1. That's 0. 1/2 divided by 3 over 2. That means I want to flip this bottom and multiply. So I got 1/2 times 2 over 3, square root of 3. So the 2's cancel out. And that's 1 divided by square root of 3. Anything divided by itself is 1. Here I'm taking this term, this fraction, dividing by 1/2. So I'm going to flip and multiply, and the 2's again cancel out, so it leaves me a square root of 3. And this is 1 divided by 0, but we know we cannot divide by 0, so this is undefined. And in fact, on the graph of the tangent of x at pi over 2, you have an asymptote. So that's how we know it's undefined. Now I'm going to take this knowledge, and I'm going to go back to my equation here. And we're figuring out 1 divided by cosine of pi over 6. So now I know that cosine of pi over 6 is the square root of 3 over 2. And we're going to square this. So when I take this divided by the fraction, that's just going to flip the fraction over and square. And that becomes 4 over 3. And this is my slope of my tangent line. Alright, so now that I know my slope of my tangent line is 4/3, I need to figure out my slope of my normal line. So remember, if the normal line is perpendicular to the tangent line, and I know that the gradient of the normal line times the gradient of the tangent line must equal -1 if they're perpendicular to each other. So that means my gradient of my normal line has to be -1 divided by the gradient of my tangent line. So that's going to give me -1 divided by 4/3. So my gradient of my normal line is simply -3 over 4. So now I have my gradient, and the problem gave us a point. So they gave us the point pi over 6. Oops. Let's move up here. So now we know that my gradient of my normal line is -3/4, and we were given the point pi over 6, comma 1 over radical 3. So we are going to use our point slope form of the equation and substitute in our point. So y value would be -1 over square root of 3 equals my slope of the normal line, x times my x value of the point, which is pi over 6. And we don't have to simplify because that's exactly how our answer was written. Last one is number 6. The first derivative of the function f and the function g is given below. How many points on the graph of f of x is a tangent line parallel to g of x? Okay, this is another trick that you'll sometimes see. It says how many. So the key is we don't really care what the numbers are, what the actual x-intercept, what the values of where these two equations intersect each other is. We just want to know how many times it occurs. And so that would be a hint. I would probably use my graphing calculator to actually look at the graphs of these two functions. The next thing you have to look at is that the graph of f of x is tangent line is parallel to g of x. So the f of x tangent line. So tangent line tells us I need to find the slope of, I need to find the derivative of f of x so I can get the slope of the tangent line. But they've already found the derivative of f of x to me. So this is the slope of my tangent line. So this equation represents my slope of my tangent line. And I know if two lines are parallel, I know for if M1 is parallel, if L1 is parallel to L2, then the slope of, oh, let me write it this way. Let's say we're given, say we're given 2 points. How do I keep doing that? try this again. Say that we're given two lines, so L1, and we want to make it parallel to L2. Well, that only occurs if the slope of line 1 is equal to the slope of line 2. So for the tangent line to be parallel to g of x, I need this slope here, the slope of my tangent line, needs to be equal to the slope of this line, which we'll call M2. So I need these to be set equal to each other. So all you really need to do is I need to know when x minus sine of e to the x equals, and the slope of this linear function is just 3/2. So I need to figure out where these two are equal. Well, how you can do that on graphing is you can set up the left-hand side of the equation as your y1, and then the right-hand side of your equation as y2, sketch the two graphs, and look at where they cross each other. So I'm going to go to my graphing calculator, and let's look at sketching this really quickly. So in our graphing calculator, we need to go to graphs, and we're going to plug in our equation here. So our first equation was x, there it is, x minus our sine of e to the x. So there's our function. That's what our graph of x minus sine of e to the x looks like. So now I need to graph another function. So I go menu, graph, function, and now it goes to y2. And so this is going to just be the fraction 3 divided by 2. Now we look like we have intersection. I'm not sure what's going on over here. I can't quite read that. So I'm going to zoom in a little bit. So I go to menu, zoom, and we'll do a zoom box. And I'm just going to highlight that piece of the graph that I'm not sure about. So I'm going to zoom in here. Let me move, oops, back. Anytime you mess up like that, it's really easy to get back. You go back to zoom standard, and it gets you back to where you started at. Now before I go anywhere, let's get rid of these labels. They're messing me up. They're going to hurt with us looking at it. So let's try again. So zoom box. Focus on that part we're not too sure about. And then I can easily see now we have 1, 2, 3. It intersects the graph 3 times. So I go back over here, and my correct answer is it intersects the graph 3 times. I hope this video has been helpful to you. If you have any more questions about the product rule or trig functions, please send me a message. Have a good day.